Alright, so now we know how to read and calculate the areas from the z table. Now to the last two parts. Last part is, well, second last part is that what if the examiner, instead of giving you the critical value, for example, instead of saying that find the probability that the weight of the apples is less than 50 grams, right? Instead of saying that, what if the examiner gives you the probability and asks you about the weight of the apples? For example, find the probability, oh sorry, the probability that the number of apples that are greater than a grams is equals to 0.025. So now they've given the probability and they're asking what weight of what weight is that probability of. So how do we figure that out? Well, my people, friendly people, this is all the types that have ever been witnessed in the exams, and we're going to attempt all of them. This, my friends, is called reversing the z table, when we have the probability and we're finding the critical value. So here we go. So this is your x belongs to a normal distribution. Here is our mean and here is our variance. Okay, so now listen carefully, pay attention for the next 20 minutes please, and we're gonna kill it inshallah. ठीक है, so now here we go. Now equals to equation over here. Now what you need to do is forget entirely, firstly forget entirely about this other part of the equation, right? Instead, firstly satisfy this inequality by forming an equation like we used to do when we were learning how to calculate areas, or and what areas we were figuring out. So how do we do that? Simple. Instead, we simply do this. Here we go. And 0, and a positive a would be somewhere around here and greater. So this region is my probability. So how do I find this region? I simply subtract 1 from phi of A. What that means is all the region, from the total region, I'm subtracting all the region that is less than A. So what am I left with? All the region that is greater than A. So 1 minus phi of A equals to, and now as you're done creating this equation, continue the equation and now you can think about the other side, 0.025. Sir, you have not completed the equation. Why did you leave that bracket empty? My friendly people, I taught you and I've again and again mentioned that when you are calculating the normal distribution values, the first step is standardizing the equation, right? Because if 50 was written here, what would you have done? You would have firstly done subtract the mean and divide by standard deviation, haven't you? Wouldn't you have? Because this value of a exists at the mean 40 and the standard deviation under root 20.8, right? It And for me to find it, I firstly need to I need to standardize it, right? Because of this standardization, this probability has occurred, right? So if I just go on with it directly, I wouldn't get the right answer, or I'd get the answer of the ideal A. I want the non-ideal way, not non-ideal A, right? Because the ideal A would be 1.69 maybe, but the ideal A will be like 50 grams, 30 grams, 40 grams, right? That is my actual answer. The standard answer is just a standard way of looking at probabilities, right? But I need the actual real world answer. So that's why I need to standardize it. So how do we do that? A was our value, subtract the mean, which is 40, divide by standard deviation. Now this is the variance. So under root 20.8. Okay. So these are your first steps. What do we do first? We forget about the other side of the equation and satisfy this inequality. How do we do that? We imagine a normal distribution curve, think about A, and then shade the region and whatnot, and then think about the inequality and equation. So for greater than A, it would have been just 1 minus phi of A, right? But we also need to standardize this A, right? So you can do that by this step. And I saved a step here. I could have done this as well. Just to be more sure of myself, you could have done it this way. Move this a little down, add one more step if you want to. It's your choice, to be honest. You can do probability that now I am idealizing this variable z is greater than a minus the mean, which is 40, and then standard deviation equals to 0.025. you can add this step to it. Completely understandable and perfect. Actually, this is quite better because first you standardize it and made it clear in your head, then you're gonna continue on. But this does not. Why did I first teach you that way? This underneath way, this whole thing. Why? Because I wanted to assure you that this subtraction in the mean and divide by standard deviation does not affect how you form an equation, right? So please, you simply will think about the same way. This point is going to now be a minus the mean and divide by the standard deviation. But the equation itself, 1 minus phi of a, is going to remain the same. But instead of a, I'm going to write this big equation. It takes some space, but this is a better way to go about it. Why? Because it is less prone to errors. Why do I say that? Because questions can be as large as asking you to solve simultaneously. So that's going to dirty up your work. You might forget a step. And to avoid that, do all this lengthy and rigorous and tedious tasks and steps. Please, I beg of you. Anyways, so now what's my next step? Now, this is an equation has been formed. This whole thing is ideal and it satisfies the inequality. The other side is still the same. For this equation, this is the probability. Now, no, 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 no. What is your next step? What you need to do is simply one thing. Make phi your subject of the equation. Phi in this bracket, make it the subject. Okay, I can do that. So one can be proceeded to there. So it's going to turn into minus phi of a minus 40 divided by under root 20.8. Bracket close equals to 1 minus 0.025 negative 0.975. Sorry, I wrote that a little different. Negative negative cancel out. That was what was going on in my head. Anyways, so now phi and this whole bracket is now the subject and 0.975 is on the other side. So but we need to find a. So just like in trigonometry, sine cos tan, remember how did we remove sine and find theta? We sent sine to the other side and inversed it. So do the same thing here. Send phi to the other side and inverse it. So what is going to remain? A minus 40 divided by standard deviation of 20.8 under root 20.8 equals to phi has been gone to the sent to the other side and inverse. Which probability is being reversed? Inversed. Phi inverse. Probability is being inverse of 0.975. Okay. So what do I need to reverse from the z table? I need to reverse 0.975. Got it. So wait. Now how do we reverse? That is the main thing, main task at hand, because the above part is basic stuff. It's not that hard. You can do it, you can learn it easily. Now how do we do this? Very simple. Firstly, the first step is whenever you are at this stage when you form the phi inverse bracket and you look at this value inside 0.975, your first mind, your first thought is going to be, okay, let me look at this smaller table underneath the bigger z table. So this is a table of critical values, of common critical values for your own ease. The examiner has given you some critical values that are common or that will be seen. They are absolutely not common. They're just given to make you feel a little better about yourself. It doesn't have, mostly questions will require one more method that I'm going to teach you, but let's do this first. The concept is important. So these are the critical values. Here is the equation. Probability z is less than equal to smaller case z, which is your critical value, equals to the probability. So for this probability, the existence of this probability will occur at this critical value. So this represents all the probabilities that are possible, right? And this represents the values at which these probabilities will occur. The values at which these probabilities of 0.95 will occur. So when I would read 1.645 from this table above, I would get 0.95 as my probability. Does that make sense? I hope it does. Anyways, so first thought should be when we've reached the phi inverse stage, we read the bracket. What does the bracket say? 0.975. Okay, first thought, look at the smaller table. 0.975. Is it in the probability column or a probability row? Yes, it is. And this probability exists at the critical value of 1.960. So 1.960. A minus 40 are divided by under root 20.8, and please you can do the rest yourself. Multiply this on the other side and this will go and add, right? I'm going to actually do it for you once, just once, and the rest you can figure out yourself. Multiplied by under root 20.8 0.8, and this whole thing, after you multiply, you add 40 to it. So what is our final answer? 1.960 into root 20.8 plus 40. So final answer is 48.9. Okay, so 48.9, and that should be good enough. If you want, you could make it. You could take it to two decimal places, but in your exam, you can leave it at 3s if it's good enough, right? So this was your first type, and this is all. This is all. This is everything. Everything is covered here. But there's one special case that I'm going to teach in the end. But let's do more practice of this whole thing. Right now, let's do it here. Probability of x being your non-ideal variable, the x could take the value of anything. In this context, I'm talking about apples. So apples that are less than t equals to the probability that this t occurs at is 0.9. Okay. So what's the first step? We forget about the other side, and actually no. Let's do it properly. Firstly, we standardize it. Always standardize because it is non-ideal. So probability z is less than t minus the mean divided by standard deviation equals to zero point 0.9. Now what's the next step? What's the next step, people? The next step is simple. To forget about this side of the equation and satisfy this inequality. How do we do that? Well, simple. Sketch your normal distribution curve. Here is your center 0, and t minus the mean divided by standard deviation is going to be a positive value. So you're going to write here t minus the mean and divide by standard deviation. And you need all the area that is less than it. So less than would just be phi of OT minus the mean and divide by standard deviation. Actually, wait, let me write these values down. Okay, there we go. So 40 divided by under root 20.8. The terrible 8, there we go, 20.8. Now, on the other side, now we can continue with the equation because this part of the equation is complete. Then we proceed to the other side, right? So now that's done. Now what's the next step? Make phi the subject. Phi is already the subject of this equation. So what is the next step? Next step, you send this phi to the other side and inverse it. So phi inverse of 0.9, right, equals to t minus 40 divided by root 20.8. So what do we get? Phi inverse of 0.9. Okay, so when we reach this stage of inverse, we read inside the bracket. The bracket says 0.9. Okay, so first thought should be go inside this table. Does 0.9 exist? Yes, it does. At which value? At the value 1.282. So my friends, if I reverse this, this would become 1.282. And then you could do all your maths to find t under root 20.8. I hope this is making sense to you. This is the easiest method I know of, to be honest. And by the way, let me make you think a little. Where and which part should I? This part. Okay, so think about it. X is greater than A. The probability was 0.025. In the end, what did we remain with? We remain with phi of A minus 40 divided by under 20.8 equals to 0.975. Sir, why did the probability change? Well, my friend, listen to me. The probability 0.025 was what region? Let's look at it this way. This is just for interest, by the way. If you want to move on, you can, but it would be better for the concept. Anyway, so there, that is a terrible curve. Here we go. Okay. So here's your curve, here is your 0, here is your A. Now, what if I talk about the region greater than it, and if I talk about the region less than it, the probabilities will be different. Yes, it will definitely be different. But does my boundary change? Does this critical value change? It absolutely does not. So that is exactly the logic we use here. Because the z table can only understand the values that are less than it, right? They only understand the values less than, the region less than, as we've done before. So, which is why when we've done this whole conversion, when we made phi the subject, what did we do? Instead of the greater region, now we are talking about the region less than it. Less than A minus the mean divided by standard deviation. My voice is dying out here. Damn. Anyways, so I have changed my probability, which is why this has become 0.975, because now it is talking about the region that is less than this boundary of A. But this value, of course, does not change. Why? Because the boundary is the same, just like it was happening over here, right? The probability changes, yes, but the value of A does not. So I hope that made sense and that caught your interest a little. Okay, sir, that makes sense. The examiner loves us. He's given us some values here. We can read and reverse and whatnot. And by the way, please solve this further yourself. I'm just saving time. Okay, sir, why have you written type 2 here? This concerned me, sir. Okay, friends, let's talk about it. Type 2 is what if the value in your inverse bracket does not exist in the small table, because this clearly contains a handful of values, what, 5, 6, 7, 8, 9 values, that's a handful, right? What about the values that may not occur, the probabilities that may not fit into this small table? Then, my friends, we go and seek our critical value from the larger table, which is this old good friend of ours. So let's look into type 2. Here we go again. Okay, so probability. What's the first step? We simply first standardize our data. So z is less than a minus the mean divided by standard deviation. Bracket close equals to 0.5280. Now that we've standardized our data, what's the next step? We forget about the other side of the equation. We firstly satisfy this inequality. How do we do that? Simple. Imagine the normal distribution curve. Always show it, please. That will cost you marks. A minus the mean divided the standard deviation is your positive side. So all the region that is less than it is just gonna be phi of A minus the mean, that is 40, divided by root 20.8. Okay, there we go. That is some terrible work. Please do your work neatly, people. This goes for me as well, which is why I'm cleaning it out. 40. There we go. And now that this equation I've made satisfies this inequality, so now I can move on and complete my equation 0.5280. Now the next step is making phi the subject. Is phi the subject? Yes, it already is. Next step, send phi to the other side and inverse it. So what is left here? A minus 40 divided by root 20.8 equals to phi inverse of 0.5280. Now, what do? Read the inverse bracket. What does it say? 0.5280. The first thought should be read the small table. Oh my god, this probability in this probability row, does 0.5280 exist? It absolutely does not. So what do I do now, sir? Well, people, you remember all these values. What are these? These are also probabilities, right? And how did we read them? We read them through all these critical values, right? And we broke our critical values into different decimal points and we read them, right? Didn't we? So what if we did the same? We used the same logic, but we thought backwards. Let's talk about that. But before we move on, I need to tell you one thing, which is just a reminder that this is your first DP, first decimal place. From this column, you used to read the second decimal place, and from this column, you used to read the third decimal place, if I am right. I am not wrong, I know that because I taught you. Come on. Anyways, so what are we reversing? We're reversing 0.5280. So in all these probabilities, in this column, in this column till here, not the add column, all this, in this second decimal place column, what do you need to do? You need to find the probability that is closest or equal to 0.5280. Let's do that together. So 0.5199 I can see here, 0.5239, 0.5279, that is the closest. If I move forward, I exceed my value. I said closest or equal, right? Not more than that. So the closest is 0.5279. So 0.5279 exists at which critical values? At which decimal places? It exists at 0.0 as the stem. And what does the stem mean? By the way, stem means zero, before the decimal place, the one's value. The zero means stem, and this is your first decimal place, right? So now we have the first decimal place, and this first decimal place coincides with what? This 7. So this 7 is your second decimal place. So we've already figured out the first two decimal places, which is 0.07. Now what did we used to do when we were reading the Z table? We read the first decimal place, second decimal place, we found the main value, the coincision, right? And the third decimal place was chosen from the add column. Now what did this add column do, people? Well, sir, the add column was to be the values in the add column are in a certain criteria. They are already in the form of being multiplied by 10 to the power minus 4. And then we used to just add it to the main value that we found using these two decimal places. In this case, we have 0.07. right? So think about it. The same way, what value out of these 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 would I read to get a value, out of these, that if I add, or out of all these, if I add it to the main value, it would add together to give me what? 0.5280. Because what did the add value do? It increased the main value and turned it into something else, right? So let me give you, by the way, let me teach you a trick here as well. So 0.5279, 0.5279. The add values are always added to the last two digits. The last two digits being 79. So if it is a one digit value, if it is a 4, you can just add 9 plus 4 and then do your adding mathematics. And if it is 11, you add 11 to the last two digits. So 11 is just going to get added. It's the same logic of adding 11 into 10 to the power minus 4. Because think about it, 11 into 10 to the power minus 4 is what? That is a terrible writing, forgive that, 0.0011. So 0.0011, same thing. So just a quicker way to think. Anyways, so what do I need to convert 0.5279 into 0.5280? I just need 0.0001. What does that mean? In the add column, I need 1, because if 1 is added to 79, it turns into 80, right? So does 1 exist? It absolutely does not. I cannot see 1 in the add column. So leave it as it is. What is your job? Your job is to find the closest critical value at which your probability exists. So 0.5280 the closest the closest critical value that I found to the actual critical value at which 0.5280 would have existed is 0.07, right? So the final answer would be here. The reversal would be 0.07. And then you can just do maths and satisfy the equation to find A. Right? I hope that all that made sense. So what is the next part? The next part states x is greater than b equals to 0.527.54257. Okay. So what do we do first? We standardize our variable. Standardize it by converting into z. Z is greater than b, subtract the mean, divide by standard deviation, equals to 0.4257. Now, what's the next step? We forget about this other side and satisfy this inequality. How do we do that? We sketch a curve, normal curve. 0 exists there. This is a positive value, so it would exist somewhere up forward the 0. So there we go. Plant that there. Greater would mean this region. Greater means this region, right? So how do I do that? So 1 minus, subtract from it all the region that is less than this boundary, and then you what will be left with? All the region that is greater than it. So 1 minus 5 of this critical value, b minus 40, which is your mean, divided by standard deviation, which is 20.8, equals to 0.4257. Because now this equation satisfies this inequality, we are done satisfying it. Now we can continue with our equation. 0.4257. Now what is the next step? Next step is to make phi the subject. Phi in the bracket, make it the subject. So let's do that. Phi was send 1 is being plus 1 is here, it goes there to subtract. So b minus 40 divided by root 20.8 equals to 0.4257 minus 1. There we go. We get, while the negative exists there, negative 0.5743 is what we got. Negative cancels out, and we are left with phi of b minus 40, 20.8, right close, 0.5743. Now, is phi the subject? Yes, it is. So what do we do now? We send phi to the other side and inverse it. Phi inverse of 0.5743. There you go. My accent is messing up. Divided by 20.8. Now we have reached the inverse stage. So in the inverse stage, what did we do? We looked inside the bracket. It says 0.5743. Does this exist in the smaller table? It absolutely does not. So what do we need to do? We need to reverse it through the larger table. So what are we reversing? 0.5743. So let's reverse this probability. So what is our first job? How do we reverse? We find the closest or equal probability to 0.5743. Okay, so 58 I'm seeing here, 5793, 5714. Actually, let's clean this up a little. There we go. Just clean it up. There we go. Good enough. So I'm seeing 0.574353 here, 0.5714 here. So if I chose this value, it would have exceeded my probability, right? So I cannot take this. But what I can take is the value right before it, which is 0.5714. So this exists at the coincides with the first decimal place and stem of 0.1 and the second decimal place as 8. So my first two decimal places have been found. 0.18. 0 is your stem, first decimal place, second decimal place. Now for the third decimal place. Now think about it again. What value of add do you need that when it is added to 0.5714, it would convert it into 0.5743. So basically, what do I need to add to 14 that it converts to 43? So let's do that. 43 minus 14. So 29 needs to be added. That means the add value must be 29 to convert this 5.5714 into your probability, which is 0.5743. So let's look at it. How do we find 29? Is 29 here? Oh, okay, 28 is here, but I cannot see 29. Does 28 get me equal or closest to my actual probability? It does not get me equal, but it does get me closest. Your job is to find the closest critical value, right? Not accurate, but closest. Sometimes you will find the exact equal. In some cases, yes. But but this is also a possibility when exactly the probability cannot be reversed. So what do? We find the closest probability, and then we take that as our critical value. So 28 exists as at the third decimal place 7. And I like the trick I told you, 0.5714, 0.5714 plus 28. 28 is added to the last two digits. So 14 plus 28 gives me 0.5742. So it's just a 1 into 10 to the power minus 4 difference, but it's negligible in our case of approximation, right? This is us approximating the critical value. Our job is what? To get to the closest or equal probability and then take that as our critical value. Okay? So what is the critical value? 0.187. 0.187 is our critical value. Okay. Now this has been reversed to 0.187 equals to b minus 40 divided by under root 20. Now find b by just doing maths. So I hope this is making sense. Now we move on to the final and last case. Okay, this was equals to 0.9, my bad. Okay. So look, take this in by the way. This is a lot of marks you have just understood. If you manage to understand this, pat yourself on the head and on the back. Just give yourself a little proud of myself moment in the mirror because this is some heavy stuff, right? That is making sense to you. It's brilliant. I'm trying my best. I hope these words are clear to you. Okay, so now let's do the final case, the last case, the trickiest case. This is a special case. A C that stars sparkling on it. That means this is important. Examiner's personal favorite question. Okay, so here we go. What's the first step? We standardize our data. Z is greater than T minus the mean divided by standard deviation equals to zero point 0.9. What is the next step? We forget about the other side of the equation. Satisfy this inequality. How do we do that? Simple. Make your normal distribution curve 0 here, positive here, so T minus the mean. There we go. Divide by standard deviation. Greater means this region, this good old region, right? So how do we do that? 1 minus phi of all the region that is less than the critical value. So what are we left with? All the region that is greater than the critical value. So the probability now continue. Now complete your equation. Now complete your equation, right? 0.9. This 0.9 written as it is. Now you're gonna make phi the subject. So the probability is clearly gonna change. You already know why. So make phi the subject, phi t minus the mean, which is 40 divided by under root 20.8 equals to, I'm canceling out the minus already, by the way. So this, okay, fine. I want negative 0.1 negative cancels out now. So now is phi the subject? Yes, phi is the subject, sir. What do we next? What do we do next? Send phi to the other side, inverse it. Phi inverse of 0.1, there we go, equals to t minus 40 divided by root 20.8. Now, what do we do when we've reached the stage of phi inverse? We look into the bracket, 0.1. 0.1 is the probability that needs to be reversed. Okay, look into the smaller table. Does 0.1 exist? It does not. Look into the bigger table. Okay, so closest or equal to zero point 0.1. Does any... Oh, wait, what? Sir, what is this? The smallest value probability I'm seeing is zero point 0.5. Nothing goes below that. The z table is helpless. What do I do? I cannot solve this. Am I losing marks here? Is this a question that is wrong? No, that's not true. Why? Because, see, symmetrically, if I talk about the symmetry of this curve, 0, 0, 0.01, 0 0.1, 0.1, 0.2, 0.3, 0.4, 0.5, the negative values will occur at this side, right? The region, this area is equal to this area, right? And this whole area is equal to this whole area. It's the symmetry of the situation, right? So the areas are going to repeat themselves, which is why the probabilities are not, the negative probabilities are not considered here. So, sir, that is a problem for me. How do I solve this question? Well, simple. Let me teach you. So, very simple. There's a method to this and there's some logic to this. The logic I'm not going to cover here. It's a challenge for you to think about how this mechanism of this method is working. Tell me in the comments, and I'll make a YouTube short later. If the participation is good, I'll make a YouTube short later explaining the logic of it soon enough. Anyway, so let's talk about this. We're back to square one, is what we're going to do. Now, see, to deal with this, we're going to use the concept of symmetry. This is your hint, by the way. Use the concept of symmetry to get this negative value of t, because the probabilities will remain the same, of course, in the reflected regions, negative and positive regions of your normal distribution curve. But clearly, the value of t is going to be negative and positive. That's going to change, right? So I'm going to be using symmetry, but I'm not going to explain it. It's your job to understand it because you have prior knowledge to it, right? So you can do it. I'm pretty sure you can. Anyways, so let's do it. So here's the law. Here's the rule I'm going to make you write down. Please do write it down. It's important. Whenever, whenever the bracket of phi inverse, the bracket of phi inverse becomes less than, not less than, equal to, less than zero point 0.5, then in all caps, I'm screaming, then subtract it from 1. What? The bracket. Only subtract the bracket from 1. Only subtract the bracket from 1 and introduce a negative sign on the other side. Very simple part of this. Simply, what did I say? Whenever the bracket of phi inverse becomes less than 0.5, okay, is it less than 0.5? Yes, it is. So what am I going to do? Phi inverse, subtract it from 1. 1 minus 0.1 is zero point 0.9. So it becomes 0 0.9. And introduce a negative sign on the other side. So let's just do it here. T minus 40 divided by root 20.8. Multiply this by minus. I'm introducing it, right? So I'm introducing a negative sign. This becomes what? 40 minus t divided by root 20.8. Because see, minus minus plus, oh, minus plus minus and minus minus plus. So plus, and this becomes minus. 20.8 equals to phi inverse of 0.9. See, now this change, what did this change allow me to do? The inverse has now become greater than 0.5. And this 0.9, now read this inverse bracket. 0.9, okay, 0.9. Let's check the smaller table first. Well, what do you know? 0.9 already exists right over here. It's a little. So 0.9 exists already in the smaller table. If it did not, we will follow the same steps to find it from here and here and here, right? So 0.9 already exists, so 1.28. 1 point, okay. So this is equal to 1.282 equals to 40 minus t divided by root 20.8. Now I'm going to do this for you because I'd like you to show you the change or the impact. 1.282 times root 20.8 and then minus what equals to, let me get you the answer. Okay. So our final answer is negative 34.15. So let's just go for 34.2. 3SM is good enough. Minus t cancels out, and the t, the value of t is, actual value of t is 34.2. This is your non-ideal value. Keep that in mind. What if I check the value before standardizing it, right? What if I check that value? What would that become? So that would mean if I continue, if I branch, let me change colors. If I branch, that's a terrible color choice, right? Pick one. Okay. So if I branch off from this step, and I talk about ideal data. So in an ideal data, t is going to be just t. I'm not going to subtract the mean divided by standard deviation, right? I'm not going to do any of that. It's just going to be phi of t instead of all this, right? And phi inverse of zero point 0.1. So again, it is less than 0.5. Subtracted from 1 minus t equals to phi inverse of 0.9. Blah blah blah. Phi inverse. So read that to become 1.282. Negative t equals to negative 1.2. Now in and now see the relationship between it. In the ideal version of the z table, in the ideal version of the standard normal curve, the value is negative 0.182, 1.282. So in your standard normal distribution curve, this value exists right here, negative 1.2. Okay? But if you look at the same thing in your ideal data, then in your ideal data, of course, it is a positive value of 34.2, right? So this is something to keep in mind. This is the relationship between the ideal standard normal distribution curve and your data that is stand normally distributed. Okay, so that is your normal distribution. That's almost everything. I just need to teach one more subtopic, which is normal approximation. Right. So this is all the types of reversing probabilities. I hope you can practice these and I help you understand them. Actually, one more thing. Here it is. The concept of expected frequency is part of your syllabus. Now, expected frequency, what does it mean? Firstly, write down the formula, probability into total number of times. Now, what does it mean? The question is going to change like this, something like this. Usually the question is find the probability that the number of apples weigh greater than 50 of the number of apples that weigh greater than 50 grams. You do all that equation making and you find the probability, right? Draw the curve and whatnot, and you do all the steps that we've done always, and we get the answer. That's one. But what if the examiner instead says, find the probability that out that, okay, no, let me better phrase that. Find the probability that out of the 120 apples, no. Oh God, that is terrible. Why I should have written this down before, but okay, wait, bear with me. I'm just human. I'm only human after all. Don't put the blame on me. Anyways, find the probability that one out of the 120 apples, how many do you expect? Find the probability that out of the 120 apples, that means the total number of apples you have, the total number of trials is 120. Out of the 120 apples that you have, how many do you expect? How many do you expect? Expect is your keyword. How many do you expect to weigh more than less than 50 grams? In this case, I made it less than 50 grams. So okay, you do that, standardize the data, do draw your normal curve, and shade the region. Then read the z table and get your probability. The probability comes down to 0.962. That's your probability. But keep in mind, they asked for the number of apples out of 120, the expectation of the number of apples. So that's when expected frequency comes in. What is frequency? Frequency is simply a count, right? And what is expectation? So expectation from the probability. That's the link from probability to frequency. So we have the probability of this happening, the apples that weigh less than 0.962. Imagine the histogram, imagine the normal curve, the bell curve forming in the data. What region of the apples will be shaded? And clearly there's a quantity on your axes, right? There's a quantity, there are bar graphs, histogram bars going across that contain the number of apples. Now, if I multiply it by the total number of trials, multiplied by 120, what does it give me? It gives me 115.4. So that means out of the 120, Always round down, by the way, round down, please. So you can round up as well. It is not an issue. The marking scheme accepts it. But if you want, you can do both. It's your choice. Anyways, but my recommendation is round down. Right, that's what I did in my exam, and I got a 50 on 50. So just a recommendation. But I'm no better than anyone else, because anything could go wrong at any moment. You have to be careful. You have to be open-minded about it. You have to use the logics. It is all dependent on logics, nothing else. If you have the logic, if you have the right idea in mind, you can get to the answer. I say this because even if it is 115.6, um, the the 116th apple does not exist, right? The lesser apples exist. That's why I said 150. Go round down always. Anyways, if you have a counter argument that I might be missing, please comment. I'd like to learn. Anyways, correct. Probability into total number of trials. I got this. So that means I got 115. That means out of the 120, 115 way less than 50 grams. And that is our answer of expected frequency when the examiner uses expect in your question and tells you the number of trials. That is another thing to keep in mind. Now I'm just gonna get you through normal approximation. That's what 15-minute video, and that's done. Normal distribution will be complete, and then we'll cover the past paper types.